everybody. Welcome to Math and Mrs. Lehman. I'm here with my lovely 6th period class.
Hi.
All right. Now, today we're going to continue talking about ratio tables. So I apologize for not uploading videos the past few days, but really it's quite a simple concept. So hopefully you weren't too lost without me. Oh. All right, anyway, we are going to go over the homework on page 21 it was, right?
Yeah.
So we did all these beautiful ratio tables and we figured out how many gallons of fish in a tank. But then your homework was on lesson 9, the exit ticket, and a father and his young toddler. All right, so I'm going to pause this to explain some things to the kids right now. Oh, this class. All right, we have a good time. Anyway, let's go through this. So it said a father and his young toddler are walking along the sidewalk. For every 3 steps the father takes. Oh, wait, I forgot this. The son takes 5 steps just to keep up. So the first thing that should be on your paper is a label right here. So father and son or toddler, whatever you want to say. All right, so father and son should be labeled there, and if we did this correctly, we should have 3 steps that the father takes, and the son has to take 5 steps with his short little legs. All right, so we're going to keep going up, scale this up, right? So obviously they took more than 3 and 5 steps. Maybe they took 6 steps, and how many would the son take? Everyone? 10. Yep, we're counting up by 3s on the father's side, so what would be next here?
9.
And this would be?
15.
And this would be?
12.
And this would be?
20.
And this would be 15, and this would be?
25.
All right, and then we have one more to go. 18 and 30. We could scale this up indefinitely. If we were to simplify each and every one of those ratios, what would they all simplify to? Olivia?
3 to 5.
Very good, perfect. They're all equivalent ratios, okay? They all simplify to the same value, which was the answer to question, the unnumbered question here. It says, what can you say about the values of the ratio in the table? You should have on your paper, they are equivalent. All right, or you'd want to say they have the same value, and you may or may not have said the value of 3 to 5, okay? All right, I'm going to pause this video while we do some housekeeping. I'll be right back. All right, so we're going to move on to lesson 10. We're going to skip around a little bit because I want to. All right, so it says the structure of ratio tables, additive and multiplicative. So what we looked at before is kind of what we're skip counting by down a column, right, on a vertical ratio table. And, you know, in the last example, we're counting by 3s for the dad and we're counting by 5s for the son. Now what we're going to look at is the multiplicative aspect of these and how they're built, maybe looking across the rows. So it says, imagine you are making a fruit salad, and it says for every quart of blueberries you add, so let's underline that, for every quart of blueberries, you would like to put in 3 quarts of strawberries. Right? So it never says how many quarts of blueberries. What does that imply when it says for every quart of blueberries? What number is implied without actually being stated? Xavier? 1. Very good. So when you see that and they don't give you a number, excuse me, it is implied that it's 1. So essentially down here what we're doing is we're making tables that are based on that ratio of 1 quart of blueberries to 3 quarts of strawberries. So if we had 1 quart of blueberry, we would need 3 quarts of strawberries. What would the next one be, everybody? 2 to 6. Very good. The next one would be 3 to 9. 4 to 12. And 5 to 15. Very good. So you'll notice right here we were adding, excuse me, adding 1 every time, right? And over here we're adding 3 every time. But what I want you to look at is how do we get from blueberries to strawberries? How do we get from this side to that side? How do we get from the blueberry amount to the strawberry quantity? Michael?
You multiply.
You're right. Multiply what?
3 by 2 because.
Nope. No, 3 by 2. What do we have to multiply to get from 1 to 3?
Every one you multiply it by 3.
Very good. Yeah, so we're going to multiply across by 3. So we know we need 3 times as many strawberries, right? So if we have 2, we multiply that by 3. We know we need 6 strawberries. If we have 3 quarts of blueberries, multiply that by 3. We came up with 9 quarts of strawberries, and then so on and so forth. So let's say, does this apply to, if we have a bigger amount? So this ratio table, again, is based off that same recipe of 1 to 3. Let's say we had 10 quarts of blueberries. How many quarts of strawberries would we need, Paula? 30. 30, very good. If we had, whoops.
Wait, it's 50.
No, it's 1 to 3. It says to have amounts between 10 and 50 for the blueberries. So let's say we have 20. What would be over here, everyone? 60. Yep. We're multiplying by 3. So if we had 30 quarts, we would end up with how many quarts of strawberries here? 90. Good. And 40 quarts of blueberries equals? That's a lot of strawberries and blueberries. All right. And then what if we had 50? Very good. All right. So what we're doing now is not only looking what we're skip counting by going in this direction, but what are we multiplying or dividing by to get from one side to the other. In this case, we're multiplying by 3, right? So we could even do that if we had bigger amounts. So let's say we had 100 quarts of blueberries. How many quarts of strawberries would we have, everyone? 300. Good. All right, 200 quarts of blueberries, we'd have? 600. Yep. 300. We would have 900. Yep, good. 400. 1,200. Good. And 500. 1,100. That is a lot. All right. Maybe it's for a big company. We don't know what's going on there. But anyway, we're going to move forward. We're not going to answer every question on this page because we kind of indirectly already talked about all of this. On the next page, it says, how are the amounts of blueberries and strawberries related to each other? The other day, we talked about multiplicative comparison statements, and that's where you say a certain amount is so many times another amount. And it could be a fraction, right? Because one amount's smaller than the other amount or whatever. So, for example, I said that my Jack Russell weighs half the amount of my Beagle, right? Or I would say my Beagle weighs 2 times the amount that my Jack Russell does. All right, so those are both multiplicative comparison statements. Can anyone tell me what the multiplicative comparison statement would be if we wanted to compare the blueberries and the strawberries? I have a few volunteers. I like it. Lonnie, go ahead.
They're all equivalent?
Nope. Nope, that's not. We don't want to say that we got to be careful with that because we don't want to say that we're putting an equivalent amount of blueberries and strawberries in because that would make it sound like we were talking about a 1-to-1 ratio, right? So the ratios would all simplify to be the same ratio, but that's not quite what we're looking for here.
There are 3 times as many strawberries as blueberries.
Beautiful, very good. So that's one of the statements we're going to write. So there are, good job, Liliana, there are 3 times as many strawberries, as there are blueberries. Because remember, we're talking about a 3-to-1 ratio, right? Strawberries to blueberries. So we want to say 3 to the 1 times, 3 over 1 times as many. We would just simplify that to 3 times as many. Now, what if we wanted to word it in terms of blueberries to strawberries? Caden, you think you can answer this one? He's going to try. He shrugs his shoulders. Sure, I'll try it.
There's 1/3 as many blueberries as strawberries.
Beautiful. Nicely done, guys. All right, so there are 1/3 I don't know what you said, but I'm going to change it a little bit. There are 1/3 the amount of blueberries as there are strawberries. All right, nicely done. So that is all a multiplicative comparison statement is. All right, sounds really fancy, but it's really, you're just kind of putting that ratio as a fraction and saying it a little bit differently. All right, any questions on this? All right, let's take a look at this crazy example here. It says the following tables were made incorrectly. So underline that because these are not correct. It's important you recognize that. So what we're going to do is we're going to go through this and pretend that table M here is your paycheck, right? So a table of your pay amounts, right? So if you work 3 hours, you got a paycheck for $24. All right? What is your hourly rate? What are you making per hour if you're working 3 hours and getting 24 bucks? What do you think, Cruz?
There will be 6.48 on the.
Okay, but how much are you getting per hour? You're getting there, but how much is that per hour?
3.
Nope, 3 times what gives you 24, Cruz? Anaya's going to help you out.
7.
All right, guys, we got to practice our math facts, all right? So 3 times what gives us 24?
8.
8. Okay. All right. Some kids are like, oh, whoops. All right, so 3 times 8 is 24, so you're getting $8 every hour, right? Now, if you work 5 hours, multiply that by 8, you're going to get $40. 7 times 8, what are you going to get?
$8.
56. Thank you, Abby. So $56. They wanted to say 52, so we need to be checking on that, right? So they paid us incorrectly that week. So 9 times 8, that is 72. And this is based off of the ratio of 1 hour to $8. All right, this one is a hot mess. We've got blue to yellow. Maybe you're mixing paint, all right? So we know that this ratio, let's base it off of 1 to 5, all right? The ratio will be 1 to 5. Now this is all wrong from here down, all right? So 1 to 5, this one would be what? 4 to what? If we use 4. What are we multiplying 1 by to get 5?
1.
Times 5, right?
20.
All right, so 4 times 5 is 20. 7 times 5 is what?
35.
Very good. And what's that, 10?
10. Yeah.
I shouldn't have crossed it out. All right, 10 would be what?
50.
50. There you go. All right, we're going to take a quick look at your homework tonight. Your homework is going to be on page 26. So it says, create a ratio table for making lemonade with a lemon juice to water ratio of 1 to 3. So for every cup of lemon juice, you need 3 cups of water. It says, show how much lemon juice would be needed to use 36 cups of water to make lemonade. So we want to get that to 36 cups of water. Now, I do not need you to make 12 rows for that to happen, okay? Just like these other ratio tables, they don't necessarily, like here, they don't necessarily show you 5 and 6 and 8, right, in this one. And down here, we were able to kind of skip around a little bit, right? Because we're looking at the multiplicative, what we multiply across here for each of those. So you do not need to make a humongous ratio table for that. I want, maybe a handful of rows, and rows go across. Now the next part of this question, it says, how is the value of the ratio used to create the table? So you want to think about what is the value of that ratio table, right? And how are they using that to make the table? All right, you can write down what you think for that one. And then number 30 says you're mixing paint essentially. Now you'll notice this, going from blue to red, it's getting smaller. We can use division as well as multiplication to look from one side to the other. So in this case, what are you dividing 12 by to get to 3? 4, right? Let's see if it's true here. 20 divided by 4, is that 5? Yes. Is 28 divided by 4, 7? Yes, all right. So what ratio was used to create the table? So essentially, what would that simplify to? That this is all based on, all right? And then how are the values in each row? So again, rows are across, and that's going across, right? And how are the values in each column going up and down related to one another? All right, that's your homework for tonight. That'll be due tomorrow. Thank you for watching Math with Mrs. Lehman. Please don't forget to give a thumbs up and